Okay, so today we will go to resonance. Resonance is a special case of case 3 where XL equal to XC or V naught L equal to V naught C. Yes or no? Yes?
Yes, sir.
So the voltage across the inductor and the voltage across the capacitor are same. So what will be your Z? Your Z will be XL minus XC whole square plus R square root. So obviously when XL becomes XC, your XL equal to XC, then this component will become 0. So you are left with, that means even though there is a resistor and a inductor and the capacitor, okay, but because the XL equal to XC, the impedance, the total impedance of the presence of all three components will only be seen for the resistor. So it will be as good as saying that there is only a resistor and other two things are not required. So the presence is not felt. Yes? Correct? So this will be the impedance of the circuit. Now we say XL is equal to XC. So what is XL? XL equal to omega L. And what is XC? 1 by omega C. Am I correct? So can we write omega square equal to LC? Yes or no?
Yes, sir.
What will be your omega? Your omega will be 1 by root LC. Am I correct? Am I correct?
Yes.
So if omega equal to root LC, what is omega? Omega is 2 pi F. 2 pi F equal to root LC. So what will be your F? Your F will be 1 by 2 pi LC. And what is this called? This frequency is called resonant frequency. Yes or no? Yes or no?
Yes, sir.
Yes. And what will be your phi?
Yes, sir.
What will be your phi? Your phi will be, for a series circuit, for a case 3 circuit, your phi is 0. Or cos phi also 1. Yes or no? Yes or no? Yes. So the case 3 LCR circuit, nothing but it acts like a purely resistive circuit. Am I correct? Yes or no? Yes. Siddhi, yes or no?
Yes, sir.
So if you draw the graph, okay, of F, your R will be like this, your XC will be like this, your XL will be like this. This is the point where XL is equal to XC, and this is the frequency. If you drop the value on x-axis, this is the F naught, the resonant frequency. Why we are doing XC like this? Because XC is equal to 1 by omega C. It is reciprocal. It is decreasing with increasing omega. With increase in omega or increase in F, your XC is decreasing. That is why the relationship is like this. But your XL is equal to omega L, or XL is directly proportional to the frequency. With the increasing frequency, the XL is increasing. So the relationship between F and omega is like this, directly proportional, straight line. So the point where the XL is coinciding or intersecting with the XC, that point on this axis is the F naught. Is it clear? Clear or not? Yes or no? Hello? Sorry guys, there was network issue. Yeah, so is this concept clear or not? Is it clear to all of you or any doubts?
Can you explain it again, sir?
Okay, so what we are trying to find out, we want to find out the resonant frequency. So what did he do? I plotted the graph between XL and F. Okay, wait. I plotted the graph between XL and F. So to plot the graph, what is XL? XL is equal to omega L, yes or no? What is omega? Omega is 2 pi F L, yes or no? So
Yes.
XL is directly proportional to the F. That means if F increases, your XL will increase. So the graph for this one will be how? Will be like this. Is it clear?
Yes, sir.
Next, XC is equal to 1 by omega C, yes or no? Or XC is equal to 2 pi FC. That means your XC and F are inversely proportional. So what is the graph for this one? It is like this. Yes or no? Yes?
Yes, sir.
And how is frequency dependent on R? Frequency and R are independent, yes or no? Why? I told you there is no phase difference, so frequency doesn't matter. So even though you are changing frequency, the R will not change, R will be constant. So these three graphs I am merging and I am writing in one graph. Sorry. Is it clear? And the point where your XC and XL are equal, that is the point, is the resonant frequency. Is it clear?
Yes, sir.
Aryan, clear?
Yes, sir, yes.
Understand, then only you if you try to remember it a lot, just the concept. Three graphs I am merging and writing in one graph. Similarly, now when I'm saying that your is Z is minimum at R, rather your Z is minimum when XL equal to XC. Yes or no? Yes or no? And Z can be XL minus XC whole square, plus r square, or z can be xc minus xl whole square plus r square, or z can be r. Out of these three values, which one is the lowest value? This is the lowest value or not?
Yes, sir.
But we know that your resultant voltage is equal to I naught into Z. So now when your Z is minimum at R equal to R, your I naught will be maximum or not? What is I naught? I naught is V naught by Z. When Z is minimum, when the denominator is minimum, so I naught will be maximum or not?
Yes, sir.
Aryan, yes or no?
Yes, sir, yes.
Simple, a fraction. If you take a fraction, 2 by 3, if I have 2 by 5, if I have 2 by 8, but if I have 2 by 1.1, I am making the denominator smaller. If you make the denominator smaller, the overall number becomes more or not? Similarly, when your Z is minimum, your I naught is maximum. That means maximum current flows at F naught. So if you plot a graph between frequency and I naught, this is the R, this is the for R. At Z equal to R, your frequency is F naught. That means maximum current flows when at F naught. So now what I am doing, initially I had my R was R. Okay. Here XL and XC, I am not changing this one. I am increasing 2R. I am increasing 2R. When I am increasing 2R, automatically, if this I naught was something like 10 amperes, I am increasing double. So automatically your current will become half or not? Yes or no? When your resistance was R, your current was, let's say, 10 ampere. I am doubling the resistance. When you are doubling the resistance, previously your I naught was V naught by R, that is 10 ampere. Now I am making R as double. So when I am making double, your V naught will be 2R. Yes or no? When this is 2R, that means it becomes I naught by 2. That means 10 ampere by 2 ampere, 2 ohms. How much? 5 ampere. So if I increase the resistance, the current is decreasing. That is why we made like this. So now if you multiply again 2, it will become 4 times. It will become 1/4 time. So this will be 2.5 ampere. Is it clear to all of you?
Yes, sir.
But only at this point, F naught. Why? Because I am not changing the values of inductance and the capacitance. I am only modifying the R. So at that same point, at that same frequency, you will get different values of I naught for different values of R. So if you increase R, your current will decrease. If you decrease R, your current will increase. Now you make it R by 2. What will happen? It will become double, 20 amperes. Yes or no? Harsh, yes or no?
Yes, sir.
Yes, sir.
समझ में आ रहा है बेटा?
Yes, sir.
आर्यन समझ में आ रहा है?
हाँ sir.
So some points to note. Please make a note. Resonant frequency, which is F naught equal to 1 by 2 pi LC, can be changed by changing L or C, L and C or L or C. Means either you change L or C or you change both. Your resonant frequency will get changed. Very important. Second, R resistance plays no role in determining the resonant frequency of the LCR circuit. R only changes the overall current. Means if R increases, your overall current will decrease. If R decreases, your overall current will increase. Fourth point, at Z is equal to R, the Z is minimum and your I naught is maximum. And circuit, the LCR circuit behaves as a purely resistive clear guys? Aryan clear? Siddhi?
Yes, sir, yes.
Siddhi?
Yes, sir.
Caroline clear?
Yes, sir.
And the final point is at resonance. What about the power? What about the power? Average power. Your average power will become Vrms into Irms into cos phi. Yes or no? What is Vrms? V naught by root 2. What is Irms? I naught by root 2. And what is cos phi? Obviously, when Z equal to R, your phi is 0. So cos phi is what? 1. So this will become V naught by root 2 into I naught by root 2. Yes or no? But you know that V naught equal to I naught into Z. Yes or no? Yes or no? But when Z is equal to R, can I write it is a normal Ohm's law? Yes or no? So what will be your I naught? So can I write I naught as V naught by R? Yes or no? So can I substitute here? V naught square by 2R. Yes or no?
Yes, sir.
So this is one formula. But what if I write if I naught equal to V naught R, so V naught will be what? I naught R. Yes or no? So instead of V naught, I will put I naught R. So what will become? I naught square R by 2. Yes or no? Yes or no? So your average power is either I naught square by R by 2 or V naught square by 2R. Is it clear? Is it clear?
Yes, sir.
And that is maximum. This power is maximum. So at resonance, the power is maximum. Clear? हर समझ में आ रहा है?
Yes, sir.
So now we will come to what is radio. So radio is nothing but a LCR circuit. Okay. How does the radio works? Radio has a small button, one volume button, and a tuner. Yes or no? Have you seen? Yes or no? And there will be a bar. If you rotate it anti-clockwise, this bar will move this side. If you rotate like this, the bar will move this side. And this is the volume button, just to give current. Means you want to increase volume. So moment you keep on changing, so you slowly adjust so that you try to get the the proper station. Let's say if it's 92.7, this will be frequency, FM, frequency modulation. Okay, so what you do, you try to match the frequency. So what exactly happens? So different stations, different, like this you will have 92.7, 93.5 FM, 108.4. So different radio stations will have different frequency. They will emit electromagnetic waves at different frequency. That means 92.7 is let's say this is something like Radio Mirchi. Okay, Radio Mirchi owns this 92.7. TRAI has allocated this frequency exclusively for Radio Mirchi. You cannot go and say, oh, I will use this one. No, this is called bandwidth. Radio Mirchi has purchased the bandwidth from TRAI, Telecom Regulatory Authority of India. Okay, so Radio Mirchi emits electromagnetic waves, all the programs at this frequency. Okay, similarly, something like Radio Chocolate, something, they will emit at this particular. So each station has a unique frequency. Is it clear? So what do we do? Now this radio, obviously we have a LCR circuit. So radio is nothing but a LCR circuit. You have this one and again this one. So what do? You modify. When you change this, so what you are ideally doing, you are changing the value of capacitor and you are changing the value of inductor, such that the frequency, what we are obtaining by this formula LC, okay, comes equal to 92.7. And the moment this frequency matches this frequency, you will be able to hear nice songs. Correct? Clear, guys? Aryan, clear?
Yes, sir.
You are not doing anything. By changing this tuner, you are actually you are adjusting the value of L and C in such a way your XL equal to XC. Obviously XL equal to XC only, but you are changing in such a way that this F0 becomes equal to 92.7. Clear?
Yes.
And what this volume does, this volume gives power. If you increase more volume, that means you are increasing the I0. So each radio frequency, each radio station will have its own 92.7. This is 92.7. This is 93.5. Let's say this is 108 point something. So what do? You slowly, you would have noticed that when you are tuning, moment you slowly are doing it, you can hear little songs. Yes or no? Slowly, but exactly when you match this one, you can hear the songs much clearer and distinct. Yes or no? Yes or no? And the volume only gives the power, that's it. It only make louder or lower, that's it. So sometimes what happens, some local maybe normally your radio stations, you cannot say that I will go and purchase 92.8. No, you are not allowed. Try will stop you. Maybe you have to already, these are, so you cannot buy anything within this one. You are not allowed. The whole thing means obviously 92.7 is given to this particular radio Mirchi, but you cannot go and say no, I will go and purchase 92.5 or I will go purchase 92.5. That is not allowed. Why? You think somebody who want to hear 92.7 will be coming slowly. Now let's say somewhere is here, he can listen other channels. So obviously the popularity of radio Mirchi will go. So each of the radio channels are distinctly apart. That means the frequency, what do you call that? The frequency difference is relatively more, so that they are distinct channel stations. Yes or no? Yes.
Yes.
And this one called width. It is called width of the resonance. It's called delta W. How much more? That means this 92.7 and this delta W is not allowed. That means if this is 92, if the omega is 92.7, then maybe it is 92.7 plus 0.5 and 92.7 minus 0.5. So maybe your this frequency will be 92.2, okay, to 93.2. And what will be delta W? How much difference? So 0.5 this side, 0.5 this side. So delta W will be 0.5 plus 0.5, that is 1 hertz. That is called width of the resonant curve. Rather we say bandwidth. Is it clear? Is it clear?
Yes, sir.
So obviously you think if the station is like this, then delta W is very, very large, which is not good. So ideally you should have your resonant frequency to be like this. So more sharper, delta W is minimum here. You see delta W here and delta W here. This is delta W1, this is delta W2. So obviously delta W2 is greater than delta W1. So which is sharp? This is the sharp. So sharpness, rather we say quality factor. So in market you get different type of radio. Maybe there are radio which is 500, there are radio of 5000, there are radio of 10,000. Why does it matter? Why does it change? Why the value change? Because of the quality factor. Obviously the radio which has the delta W less, the price will be higher. Yes or no? Because you can easily connect to the station and the resonance is very clear. So the quality factor decides what will be the cost of the radio. Clear?
Yes, sir.
Aryan, clear?
Yes, sir.
So ideally you should have lesser bandwidth. Delta W should be minimum. Then only you can hear the station clearly. So what is this delta W? Delta W is nothing but R by L. So if you have a circuit where you have a capacitor, you have inductor and a resistor. So if you want to make your delta W smaller, make your R by L in such a way it is minimum. So R by L, the ratio between the resistor and the inductor, gives the value of delta W. Clear? So if this is the delta W naught, this is W1, this is W2. Obviously W2 minus W1 equal to delta W. Yes or no? So what will be W1? Your W1 will become delta W. Obviously, W1 will become delta W. No, no, sorry, not W. W1 will become delta W. W1 will be omega naught, W omega naught plus this delta W by 2. So, W naught minus delta W by 2. Why? Because this whole thing is delta W. This half thing is how much? This much is delta W by 2. Yes or no? Similarly, your W2,
Yes, sir.
this one, W2 will be how much? W naught plus delta W by 2. Am I correct? Yes or no? But you know delta W is R by L. So what will be delta W by 2? R by 2L. Yes or no? So
Yes, sir.
your W1 will be W naught minus R by 2L and your W2 will be W naught plus R by 2L. Clear? So your resonance is sharp if your R is large and L is no 1 minute. We want to make the delta W to be smaller, no? Obviously, when you want to make it delta W smaller, you want to make this quantity smaller, yes or no?
Yes.
How do we make this quantity smaller? When your R will become small and your L should be large. Am I correct? Yes or no?
Yes, sir.
Yes, sir.
So you should use your resistor and your inductor in such a way that your R by L is smallest, least. Then your delta W will be least. Is it clear?
Yes, sir. Yes, sir.
Next, we come to quality factor. What is quality factor? Your quality factor is nothing but resonance frequency divided by bandwidth. So, what is the resonance frequency? F naught. And what is bandwidth? Delta W. What is your F naught? Your F naught is 1 by 2 pi LC. Am I correct? And what is delta W? Delta W is R by L. So, let us substitute the value. 1 by 2 pi LC divided by R by L. Correct? Yes or no?
Yes.
So this will be 1 by 2 pi root L into root C and up will go L root L into root L by R. So 1 root L gone. So we are left with 1 by 2 pi R root of L by C. Clear?
Yes, sir.
So your quality factor formula is 1 by 2 pi R root of L by C. Don't get confused. Why? F naught is 1 by 2 pi root 1 by LC. This is L by C. Look similar, but don't get confused. So, you should, for a better, sharper resonance or better tuning, your delta W should be minimum such that your quality factor is maximum, which implies that R should be minimum, your C should be minimum, and L should be maximum. Clear?
Yes, sir.
Any doubts?
No, sir, understood.
So you are left with LC oscillations and transformer. Okay, maybe one more class we will finish this.
Yes, sir.
Okay, so Saturday class evening we will have LC oscillations and transformer, that will finish. And Sunday evening class we will do this one, what, semiconductor. So Carolyn, you need not, if you want to be there, you can be there, but I don't think it is required, because semiconductor we are teaching this one, what do you call that, photodiode, solar cell. Is it there in your syllabus? I don't think it is there, correct?
It is there, sir.
Oh, you want to
I
attend
will
then?
attend. Yes, sir, I will attend.
Great then. Fine. Sunday. Saturday.
Okay.
Saturday same 6:30. I will let you know. Okay. Timings.
Okay, sir.
Okay. Chalo. Take care. Bye.
Bye, sir.
Thank you, sir.
Thank you, sir.
Happy Sunday.